Section 12.3. I think the derivation for the derivative is important to go through, so I'm going to go through a little bit of notes here. We already know that x is equal to r cosine theta and y is equal to r sine theta, but r could be a function. It doesn't necessarily have to be a number. It could be a function using theta. So I'm going to replace the r with f of theta. Now, if I did the derivative of x, that would be a product rule, so it would be the first times the derivative of the second plus the second times the derivative of the first. And if I did that for y, y prime would be the first times the derivative of the second plus the second times the derivative of the first. So if I'm trying to find dy over dx, I want to put the two of these together, and I'm going to get, if I do it, I'm going to rearrange the x prime so that the negative sign is in the middle. So this piece is going to go second. So if I do that, I'm going to rearrange the other one too. I want the derivatives first. It makes it easier to remember what's happening. So for y prime, we get f prime of theta sine theta plus f at theta cosine theta over f prime of theta cosine theta minus f at theta sine theta. So that's our rule for taking the derivative, which also, remember, that's going to be the slope of the tangent line. So for example 1, they want us to find all the slopes of the lines tangent to the circle where r, who is f of theta, is going to be 10. So that means that f prime at theta is going to be 0. So now dy over dx is going to be, the formula says f prime, so 0 times the sine of theta plus f of theta cosine theta over dx is going to be f prime at theta times the cosine of theta minus 10 sine theta. So this turns into negative cosine theta over sine theta, which is negative cotangent of theta. They didn't ask us to find any of them, but we could check a few points. Remember, this is slopes on a circle, radius is 10, so I'm looking at a circle where this is 10. And so if I start plugging numbers in, if I'm looking at theta is pi over 2, which would be, and when I write on this, it's going to already show up. It's going to be the tangent right through here, which should be 0. The slope is going to be 0. So let's check it. We're doing negative cotangent of pi over 2. That is true. Pi over 2 gives you 0. Okay, and the same thing's going to happen when I do 3 pi over 2. That will also be 0, so that's the guy down at the bottom here. And on the circle at the point 10, 0, x and y, that would be theta equal to 0, negative cotangent of 0, oops, not cosine, cotangent. Oh, I did it up here too. That's undefined, which does make sense because that would be a vertical tangent. I'm not going to draw on that graph because it's going to be a mess. And likewise, if I did theta is equal to pi, I would have another vertical tangent, and that's another place where it's undefined. So yes, they are making sense, and they did a few more in the textbook. Okay, example 2. Find the points on the interval from negative pi to pi, that's an odd interval, in which the cardioid r equals f of theta is 1 minus the cosine of theta. We're looking for verticals and horizontal tangent lines. Okay, so according to my rule, my derivative is going to be, let's get f prime. f prime of theta is going to be sine theta. So dy is going to be f prime at theta times the sine of theta plus f at theta times the cosine of theta over dx is f prime at theta times the cosine of theta plus, no, not plus, sorry, minus f at theta times the sine of theta. Okay, so let's clean this mess up a little bit. This is going to be sine squared theta plus a cosine of theta minus a cosine squared of theta. On the bottom, I'm going to get a sine theta cosine theta minus a sine theta plus sine theta cosine theta. Okay, so what can I do with that? Let's change the sine squared in the numerator to 1 minus cosine squared. So now I have this. And on the bottom, can I do anything to that? I can combine. I will have 2 sine theta cosine theta minus sine theta. Okay, on top, combining, I get negative 2 cosine squared of theta plus cosine of theta plus 1. On the bottom, I could factor out a sine. It'd be nice if something canceled here, but I don't think anything's going to cancel. I'm going to get left with a 2 cosine minus 1. Yeah, this isn't going to be pretty. If I factored the numerator, I'm going to run out of paper here, so I'm going to go up here. Pulling out the negative sign, this would be a 2 cosine theta cosine theta. Negative 1 here and a positive 1 here would do it. And so nothing's going to cancel. Okay, so horizontal tangents are going to happen when the derivative is 0. So that means when the numerator is 0. So since I factored that, the question becomes, when is this 0? That's going to happen when the cosine of theta is equal to negative 1/2 or the cosine of theta is equal to 1. Well, this one's easy. This is theta equals 0 degrees. The other one, if I'm looking at all students take calculus, cosine is negative in the second and third quadrants, so there and there. And when is it a half? It's a half at pi over 3 for a reference angle, which means that this is happening at 2 pi over 3. And I can't go to 4 pi over 3, but I can go backwards because my interval went negative pi to pi. So negative 2 pi over 3. The next question is, when does it have vertical tangents? Well, that's going to happen when the denominator is 0. So I'm looking at, and let me just draw some lines here to separate this mess. Sine theta is 0, or cosine theta is a half. The sine of theta is 0 at zero pi and negative pi. And we actually already have 0, so that particular problem, the vertical tangent, it's not going to be there. It's like a cusp or something. It's a weird piece because it's a cardioid, so that would be where that point comes in. The other one, when is it going to be a half? Okay, now we're in the first and second quadrants. Still pi over 3, so it's going to happen at pi over 3. And where else would it be? Negative pi over 3? think I said first and second. First and fourth quadrants. So the other one is negative pi over 3. So we have our vertical and our horizontals. The point 0, 0 on the curve, you got to handle that carefully because it's 0 in the numerator and in the denominator. And that's that little cusp that happens. And you can go through and use L'Hopital on the derivative to figure out what's actually happening there. But the slope is 0 at 0, 0. And that's the end of number 2.